In this video, we will start by talking about resource organization, and then we'll talk about tagging and naming, and also blob anonymous access settings, file share protocol settings. Then we will talk about network access, which is one of the most important things to think about. And then authentication, which I would say is the second most important thing to think about when deploying a storage account. So we'll talk about access keys, SAS tokens, OAuth, and then we will talk about encryption, Defender for Cloud, redundancy, data protection settings, so that includes soft delete and backups. And then we'll talk about secure transferred, management logs, and Azure policy. Okay, so the first step is to decide where you will deploy the storage account. This is what we call resource organization within Azure. So as an organization, you should do a deep dive into what Azure landing zones are and create a tenant architecture that fits your cloud adoption plans. Microsoft has a lot of documentation, reference architecture, and recommendation in terms of cloud adoption, and to know what type of Azure landing zone is the best for you. In simple terms, for this demonstration, we need to think about the resource group, the subscription, and the management group where this will be deployed. So here in my management groups view, you can see that I have two subscriptions. So I have one subscription that is the management subscription within the platform management group. So this is where I will store the security logs for the storage account. This is where I would also store any automation or any other resources that are related to security where I would have a restricted access. And for our demonstration, the storage account that we will be configuring is within the demo subscription here. So this is, but generally speaking, keep that private. You shouldn't have anything public unless it's really a business requirement. And now if I click on that container, we can see here the setting. Currently it is blocked at the storage account level, so I just cannot change that setting. Now let's go see file shares. So if you're using a storage account for the file service, there are a few specific settings to look at. So there is the identity-based access here. So this is where you will decide how to give user access to your file share, if that's the way that you will use that. There's also something that's pretty important, which is the security here. So by default, it's going to be at maximum compatibility. What you want to do is to change the protocol settings, put it at the maximum security, and at least try using it that way. Anything that's modern should still work. It can happen that some old application need some old protocols, but basically what you want is NTLM to be disabled and SMB 2.1 you want it to be disabled, and then other than that it can make sense. Just make sure that you try the most secure before downgrading. There's also the soft delete setting here, so it's by default to 7 days. Always make sure that you have some soft delete, just to be sure that you can recover files if you need to at some point, but the 7 days makes sense. Usually over 7 days you will be using backups to recover your data, so that makes great sense. Now let's go into networking. So networking is a pretty big part of security for a storage account. So the most secure way to allow access to your storage account is to use private endpoint connection and completely disable public access. So what you would want to have is this to be fully disabled, and here you create some private connections. So that means that you will create a private endpoint for your storage account in a subnet somewhere, and that will give a private IP address to your storage account. So then you can use just regular network routing and NSGs to allow or block network access to that storage account. And the private IP, the private point or the domain name, they must be reachable by whatever is accessing that storage account. So whether that's a user, a virtual machine, a function app, or anything else, it just needs to be reachable. And if it's reachable, they will be able to access it. Here in my current situation, I don't have anything set up of that kind. I don't have a VPN or anything like that. So if I would set that up, I would lose access. So this is really the most secure way to configure network access to the network. In order for your storage account data to be compromised, somebody would have to compromise the network first. They would have to get a foothold in your network to be able to access it. So that's really the most secure way to do it. Now the second best in terms of security would be to go with that middle setting here, which is enabled from selected virtual networks and IP addresses. This allows you to configure an ACL for the public endpoint of the storage account. So the storage account, it stays reachable from the internet. It stays accessible to its public endpoint, but you will have an ACL with an allow list of what IPs and what IP ranges can reach that storage account. So it's not the best, but it's still not too bad, I would say. So there are basically two things here. So there's the part where you will allow a specific IP. So you could allow my specific home IP or my specific public IP from my office. You could allow it there, maybe be from a provider or something like that. That could make sense. And you can also allow some virtual networks here. So you will, using that, what you will do is to deploy a service endpoint for the storage account within a subnet. And then you can allow that subnet to reach your storage account. So that's how you would configure that. And now the worst setting is to enable network access from all networks. So this is something that you should avoid because it will allow any IP from anywhere to reach your public endpoint. And then the authentication layer becomes your only line of defense to prevent a security incident to your data within that storage account. So you should avoid that, especially if you're using weak authentication. Now let's talk about authentication actually. So here we can see that each storage account will have two shared access keys. We can see here the key 1 and the key 2. These keys, they give full access to the storage account. There are two of them, and the reason for that is that this allows you to rotate your keys without any downtime. You can change all your applications to the second key, and then you rotate the first, and then you change them back to the first key, and then you rotate the second key. So that's how it works. So you should avoid using those keys as much as you can and fully block them. But if you cannot do that and you must use them absolutely, then what you should do is to set up some rotation reminders and do rotate those keys regularly. Shared access signatures are not the most secure, but they are better than using the shared access keys directly. So basically this will create a token with some specific access that can be restricted, as you can see here. You can set a maximum duration, you can set some limited permissions, you can set an expiry date. So that's already way better than our previous access keys. So as you can see here, I could remove the write access, I could maybe remove the delete access. Maybe I want to restrict that to only blob. Maybe I want to make this available, usable for only 1 day or 2 days or something like that. Shared access signatures can be created at different levels. Here you can do it at the storage account level, which is very broad, but look at this. You can also go at the container level. So here I can create the same kind of signature, but specific to that container. So it will not give access to everything, but only to that specific container. So if you have multiple containers, this does limit the scope of permissions. So again, the key with this type of authentication will be to have a limited duration, like we see here. So we need an expiry time, and you have to make sure that you rotate them regularly. So don't make them available, don't make them usable for too long. I would not like to see a shared access signature that is valid for several years, for example. It should be limited in time. There's also the option of storing the SAS token or the storage access key inside a key vault and then setting up an automated rotation. So the secret could be rotated in an automated way and people are just accessing that key vault and accessing that secret within there without ever accessing the key or the SAS token directly. Again, that's better than using access keys, but it still is not the best way to do it. The best option in terms of authentication for storage accounts is to just fully block the use of shared access keys. When you block the use of shared access keys, you also block the use of shared access signatures at the same time, since it's using the keys. So the best way is really to use OAuth and use Azure Airbag to give access. So just show you the best setting in terms of authentication is to disable this right here. And once you disable that, nobody with keys and SAS token can access your storage account. But that means that you should then go into access control here, and you will have to give some role assignments to whatever identity is accessing your storage account. Here in our case, you can see I gave the storage blob data contributor role to my account. So this is a built-in role that gives me access to data within blob containers, so I can read and write data there. So there are several roles that you can use, and this is really the most secure way to use authentication for your storage account, for blob at least. Okay, now the next thing is encryption. So in terms of encryption, there's a few settings. For most organizations, Microsoft Managed Keys without anything fancy will be the way to go. If you have any specific requirements about encryption and keys, you might have to manage them yourself in a key vault using customer managed keys. That does happen. Some of the settings here can be configured at the creation, and you won't be able to set them up later, like the support here for CMK. You set that up at the creation of the storage account. And infrastructure encryption, this is also something that you set up at the creation only. Understand that the data within a storage account will always be encrypted at rest, even if you don't use anything fancy there. So there's always a 256-bit AES encryption, which is enough for almost all use cases, for most use cases at least. You can have encryption scopes here that will enable you to have different keys for different scopes. So maybe you have a container with some key, another container will have a different key, something like that. But to be honest, if you need to use CMK, infrastructure encryption, or even encryption scope, it means you probably have some pretty big compliance requirements about that, and you probably are a bank or some type of an organization like that. So otherwise, if you're not that kind of organization, don't waste too much time looking at encryption. This is not really the most important stuff about storage accounts in terms of security. So the next thing here is Microsoft Defender for Cloud. So this part here is pretty important. With this, you can get some threat detection and also some malware scanning for files within your storage account. So this is pretty important, especially if you have a storage account that is publicly accessible, or if you have users that are uploading files to it. So in that case, you probably want to have some malware scanning in there. So generally speaking, think of that as the same thing as your antivirus or your vulnerability management software in your virtual machine. So there are two types of features. You have the features that are the posture management features, which help you make sure it has the good configurations, that it is secure. And you have the threat detection and malware scanning, which really is more like a workload protection feature where you detect behaviors and you detect malware and that type of stuff. So generally for anything production or anything containing sensitive data, you should have those features enabled. So in terms of redundancy, what you have to think about is your disaster use cases. So what happens if there's a Microsoft data center that has a disaster? So let's say all my data is within US East 2, and US East 2 has a big disaster. There's a hurricane or something, or maybe there's a fire, and I lose access maybe permanently to any data there. Maybe it just gets destroyed, or maybe it's a temporary loss of access. There's an electric problem or a network problem, and I lose access for a few hours or a day, or maybe just a few minutes. So how can you handle that? Do you mind losing that data for some time, or maybe for a permanent time? You have to ask yourself those type of questions in order to identify what is your requirement in terms of redundancy. So the less expensive and the less redundant setting will be LRS, which is locally redundant storage. So what that means basically is that all of your data will be within a specific zone or a specific data center, but you will have some hardware redundancy there. So what that means is that if there's a server that breaks, you'll be fine. If there's a network switch that breaks, you'll be fine. But if there's like a big storm, a fire, a problem that affects that whole data center, then you might lose your data, maybe just for a few minutes, maybe for a few hours, maybe for a few days, maybe permanently. So just think about that. How bad is it for you if that happens? And just don't forget, you might also have backups. So maybe LRS is fine for you since you have also backups that are somewhere else. Or maybe your backup will be geo redundant, but not the storage account itself. Just think about that. Then the next thing would be ZRS. We can see here ZRS, which is zone redundant storage. So what that means is that your data is copied in multiple availability zones within your region. So if you have a region like US East, well, there's at least 3 copies of your data in 3 different data centers. So for you to lose access to your data, you would need a disaster that affects all of them, that affects the whole region. So that can happen, but that's pretty rare. And then the next thing is GRS. So with this, what you have is that your data is replicated within a secondary region. So in our case, we have US East 2 and Central US. So my data is in those two regions right now. So for me to lose access to that data, even for a temporary time, those two regions would need to be affected by that disasters. So that happens even less often. And then there's also the setting that we currently have, which is read access GRS. So this is the default setting for storage accounts that are being created. So what that means is basically you have your data within two regions, but the secondary region is only read only. So if there's a disaster currently in US East 2, I would still be able to read my data, and of course I would not lose it, but I won't be able to do any write operations during that disaster. And once the disaster ends and there's a failover, there's a failback actually, then you will still be able to do those write operations. So if it's an application using that storage account, you might have to think about what's going to happen with the write operations during the disaster. Maybe you need to keep some kind of queue enabled to do them afterwards, but still that's pretty good. And then there's also some fancy stuff like GZRS and RA GZRS, but honestly that's pretty expensive, and that's really for some specific use cases. We don't see those pretty often. Most people will use LRS, GRS and ZRS for most things, and actually ZRS is probably one of the most frequent ones. And understand that the more places, the more data centers where your data will be copied, the more it will cost you. So of course LRS is the cheaper, and when you go up it gets more expensive every time. So ZRS is more expensive, RA GRS is even more expensive, GRS even more, and etc, etc. Here we can see that by default you will have soft delete enabled for 7 days, which is actually pretty good. Generally over 7 days organizations will use backups to recover lost data, so I would recommend that you configure backups to a recovery service vault using this setting right here. You can also do it from the vault. You don't need to do it especially from the storage account, but I would really recommend that you keep like a 7 or 14 days of soft delete, and anything over that I recommend sending that to a recovery service vault. Just make sure that your vault is well configured so that if you have an identity that is compromised, that they cannot go delete the storage account and then just go delete the backups in the vault or delete the vault itself. Just make sure that the vault is actually secured. So now let's go back to general configurations. So here there's a few things that you need to look at. So first of all, secure transfer. So by default that will be enabled, and it should stay enabled like that. So basically this will just block some protocols that do not encrypt in transit. So basically if there's HTTP without TLS, it will be blocked. There's some versions of SMB that will be blocked. So that should always be enabled unless you have some very, very specific legacy system that needs those, but just avoid disabling that. And now there's also the blob anonymous access. So that's pretty good. Now it will be disabled by default. So that's good. Keep it like that unless you have a specific business requirement. This is really related to the unauthenticated access that we saw earlier. And now there's the shared access key. So this here, it's going to be maybe a little bit more difficult to disable, but you want that to be disabled and only use OAuth for authentication. This is really to avoid. This will block you from using the access keys here and the shared access signatures also. So this is really a best case scenario to block that. And then if you do have to use access keys and you must keep that enabled and you might be using shared access signatures, well, I hope you do, then you should set up an upper limit for those shared access signatures. It should be something that is maybe 30 days, maybe 90 days, but certainly not something with that would be several years. You want to avoid that. And then there's also the default to Microsoft Entra authorization in the portal. So you should set it up to Entra as a default, and just make sure that if you use something else at Entra, it's going to be because you need it, not just because it is the default configuration. And then there's also the TLS version. So, well, by default it's going to be 1.2, which is good. It wasn't always 1.2 the default value. So just make sure that that's what it is. And at some point 1.3 will probably be available, so you might set that up. And the last setting there is the permitted scope for copy operations. So this is something that will only be used for things like object replication. So if you're not using those, just put it to the strictest configuration that you can. And if you have to use it, then you will see. But just generally speaking, it should be like that to limit it as most as you can, unless you need to do otherwise. In terms of logging, you may want to have a log entry every time somebody reads a file, maybe every time somebody writes or deletes a file. This is something that you should configure in that diagnostic settings blade. So you will often have a compliance requirement to log any read access to sensitive information like personally identifiable information or that type of stuff. So this is where you would set that up. So you can see here that for the blob service, these are the things that I can log. And of course, those logs, I should be sending them to my management subscription that we saw earlier. That is within another subscription than this one, where I can keep security logs in a segmented way. In terms of log, there is also the activity logs. So this is really a subscription level setting, but you should be exporting your activity logs to that management subscription there, because these are security logs. And if you have an incident that happens, you will want to have those logs to be able to look at them and understand what did people do, what users were compromised, what were their actions. This is really something that you need to have somewhere. Another thing that you might want to look at is management logs. So once you have your storage account set up, it's created, and you're gonna go to production with it, you're gonna start putting some data in it. If it's a critical storage account or if the data in it is critical, you should configure a management lock right here. Or it could also be at a resource group or subscription level. You can do it at those 3 scopes. For all the scopes, you're gonna have the same lock types available. So for anything critical, you need to have at least a delete lock type. So what that does is that somebody cannot delete the storage account. That's what it does basically. So it avoids any mistakes where somebody would delete it by mistake. Maybe it's a pipeline with access and somebody does a mistake and they delete the resource. Maybe it's a compromised identity that tries to delete it. This would prevent that. And then there's only somebody with the owner or role that can remove the lock to be able afterwards to delete the resource. And there's also the read-only lock. So this is a little bit more difficult to set up because sometimes it will block more things. But if you can set it up for production workloads, that's a good idea, since it will make sure that it stays just as it is, unless there's an owner that removes the lock. So this will prevent, for example, organizations where you have a lot of developers with a contributor role. This will prevent them from doing some things. Since a contributor cannot remove a lock, well, they could not be able, for example, to delete production resources. So now the last thing that you should consider in terms of security for your storage account is Azure policies. So here in policy definitions, we have a category specific to storage that we can use. And here we can see that there are several built-in policy definitions related to storage. So you can see them. There are things about public access. There are things about blob versioning, all that type of stuff. So you should make use of those policies in order to do 2 things. First of all, you should use them to make sure that somebody cannot change that setting without removing the policy first, or without involving somebody from the security team. Usually policies will be managed by somebody else, another team, a security team, a governance team. So people, if they want to do something else than what is defined in the policy, they have to ask permission, either to remove the policy, modify the policy, add an exclusion, change the scope. So that would involve that type of process in order to do something else. And also with policies, what you can do is that any new storage account created within that same scope will have the same configuration. So if you decide that shared access keys are disabled in all your storage accounts and you put the policy there with the deny effect, well, any new storage account within that scope will have shared key access disabled. So that just makes sure that the default configuration is as you want it. In summary, in this video, we talked about a lot of subjects. One of them was resource organization. So we discussed that you need to think about having a landing zone within Azure. If you're not deploying a full landing zone, at least you should have some type of segmentation between security related resources and application resources. In our context, when we are deploying a storage account, that means at least security logs about the storage account should be sent to another subscription. Then we talked about tagging. In terms of tagging, you should think about adding some useful metadata like owner, criticality, data classification created by that type of information to the resource group and to the storage account. Then in terms of naming, we talk about mostly Microsoft naming recommendations. That means you should look at the official abbreviations for resource types. what are the different recommendations in terms of adding maybe the region, maybe the stage, the workload name, and some number to the name of resources. And then we talk about blood anonymous access, so that should be disabled unless you have a specific requirement for it. In terms of file share protocol settings, you should go with maximum security settings whenever you can. So that means basically to disable NTLM, disable some older versions of SMB when you can. In terms of network access, we discussed that the most secure configuration that you could set up would be private connections and disabling completely public access. That's really the most secure way to use storage accounts, but sometimes you will have to do otherwise. In terms of authentication, again, the most secure way to do things would be to disable key access and use OAuth 2.0. However, this is something that you cannot always do, and when you cannot, you can still use SAS tokens. In terms of encryption, well, as we discussed, there is some built-in encryption within Azure, which for most use cases will be enough. However, if you need more, if you have some compliance requirements, there's a lot more that you can do with customer managed keys, infrastructure encryption, and also the encryption scopes. About Defender for Cloud, you should enable for storage and for any other type of resources within the Azure Cloud, you should enable the CSPM and the CWPP features. That means for the CSPM features that are going to help you monitor misconfigurations, making sure that things are configured securely. And for the CWPP, these are features that are around workload protection. So we're thinking here detecting dangerous behaviors, analyzing files for malware, that type of thing. In terms of redundancy, in my experience, zone redundant storage is pretty much the minimum for any production workload. You can still have better redundancy with GRS and some other settings, or you could have a lower one with LRS, which is also cheaper. But usually most organizations that I have worked with, they go with a ZRS as a minimum. In terms of data protection, well, soft delete is enabled by default, so I think you should use it. Usually a 7 or 14 days of soft delete makes sense, and then you should complement that with some backups that go to a backup vault or a recovery services vault, so that you can keep this data for a longer period. Secure transfer is already required by default, and you should keep it that way in order to require encryption in transit for your storage account. Management locks, or resource locks as some call them, should be deployed in production. So whenever you have some critical workloads like a storage account and you don't want it to be deleted, you should deploy a lock on it. In terms of logging, well, we talked about diagnostic settings where you can log write operations, read operations, and delete operations. So that is often required for sensitive information whenever you have some of that in your storage account. If you don't have any of that in it, maybe that's not a requirement, but you should at least think about it. And then you have activity logs. This is a subscription level setting, but you should export them to your management subscription at minimum. Also think about retention, which should be more than 30 days. And then at the end, we talked about Azure policy. So Azure policy should be used to secure your storage accounts. There's a lot of built-in policies that you can deploy. So that can be used to do two things pretty much. So the first thing you can do is to ensure that the configurations, they will stay as is for the future. So if you want to disable key usage, well, you can have a policy in deny effect that will disable it and make sure it stays that way. It will also help you make sure that future resources also follow those policies, so you can have a sort of default configuration that is more secure than the otherwise default configuration. Thank you very much for watching. Don't forget to subscribe. Have a nice day.